This video will be about electrical outlet wiring, standards, code violations. You're going to watch code violations. And I'm going to discuss the backstabbing issue. Electrical outlets in the United States specifically. Okay, here we go. I'm going to show you, if any of you have done rewiring, some of you are going to have a knee-jerk reaction and start throwing things. This is actually a meme on the net. I'm not trying to do that to you. Okay, now, first of all, this is an example of one way to wrap the wire onto this thing, and this one here is using that example up here. This one is using a different version of it. You may have noticed that there's a prominently stuck out piece of metal there. It's sticking into the space, and it's taking up the space. And if I move it up and down or back and forth, it doesn't move. Now I'm going to deliberately loosen it. I'm going to let you watch me loosen this. I'm going to rotate. Oh, God, you can't even see it. Okay, I'm going to loosen it by rotating it 1/8 of a turn loose. Now this is loosened. It's still holding. In fact, it can do that very, very well. Now that is not done by using a pair of pliers, which means it doesn't get nicked and it doesn't get weaker. You only bend it once, although I did end up bending it a second time. Bending it more than once will work harden it and make it less strong. Okay. This is one where I did the standard thing of you wrapping it around a screwdriver or using a pair of pliers and just getting it to where it's a hook and it'll fit on there, okay? This one's different. Now, this is how much movement it has. This one can't move even when I loosen it. I'm going to show you how to do that. But the reason for that is it's wrapped around it. It's got good coverage. It's not sticking out any wire. But that extra wire acts as a leg because this is in a little pocket here, and pressing that copper into the pocket keeps it from moving. And a lot of you might have come up with this idea and thought that's a great idea. As long as you don't bend the wire out in weird angles, that will hang on tightly and it won't come loose. It's extremely reliable, and you can get away with doing it. Now, the next step of it is, you may have noticed this, don't do that, is to make sure you put kind of a wiggle-waggle bend in it to where if you do put it into a push socket or twist nut or one of those little toggle clamps that are really awesome and I really like them, or just whatever you're using, if you do that, make sure that you put a couple of bends in it, an S-curve, so that it will flex a bit as you put it back in the socket. The more the wire flex, the more breakable it is. Make sure it's still in the insulation. The insulation is also there just in case the wire breaks, so it doesn't get loose and snap against a metal part and blow up. Now, you might think, okay, well, we just retighten this. The more you tighten this, the more you rafe down on it, the more likely you are to stress the socket or the switch. So the way to tighten one of these that's going to, it's literally flopping loose, is put it in the loosest position possible. And this is so counterintuitive, don't do it, but this is how you have to do it. You tighten down your screw, in this case, depending on the one you have, really, really tight while holding the wire. Then when you put the wire back here, again, this is a mirror image video, as you do that, it'll have a tendency to unwind itself, but it doesn't. If it's so loose that it can slide in the socket like that, it's not going to uncurl it, it's going to make it tighter. Now, when I pull this down, it'll still loosen it, but it's not as loose. Now you see why I've always done it the other way, where you use the little plastic guardrails in the screw socket area to form this better. I'm going to demonstrate how to do it really quickly. This is what little I can contribute, which isn't much. Okay, you unscrew this. By the way, when you're done with these things, make sure you put those screws in very, very far, because a bug or a mouse or whatever gets in the wire outlet socket or whatever, it can start a fire, so don't do that. You place it. Now remember, you want to wrap it to where it'll always tighten it. You want it to do this shape, mirror image, which means it wraps around clockwise for your perspective. Place it on one side of the connection like this, and make sure that it comes really close to, but not exceeding the side of the thing. Press it in with your finger and wrap the wire mechanically around the screw until it comes out the other side. When you're doing this, you can often do it with one hand only, but don't. And then you press it in to where it fits into the socket barely, to where it just barely snugs in. And it takes up as much of that round as possible. Now, the reason you wrap it around the screw is so that it has a tight radius around the screw, so that when you tighten the screw down, all of that part that's the nice round surface is underneath the screw. And again, you have to make sure that the wire is still within the guards, the plastic guards on that screw terminal area. And I'm fighting with it a lot here, but it eventually goes in. When you do that, it's almost sprung loaded to where it can no longer move again. Now, I've done it. Now, you can see there, it's got that wire sticking out. And you try to move, it fucking won't move. It's the most reliable way of doing it I've ever done. And there's a weird trick to making sure that that does not have any conductive surface there to hurt anything. When you strip the wire off, you strip it just slightly longer than the little wire strip gauge that's often on the back of these. That's not meant for this, but you can use that. People do it anyway. And when you wrap it, your insulated area won't be outside of it, so it'll be insulated. But you can leave a little bit of insulation on the end there. You might think of doing that, and that'll work. No, it doesn't. It never works. When you do this for the high reliability, vibration-proof type wiring, taking advantage of the plastic being shaped literally as a wire forming tool built into it, you have to wrap it with tape. No exceptions, because that is a bare surface that's just barely able to make contact with a random object. And to illustrate it, I'm going to show you the backstab connection, which is, it's a wire insert. It's a wire connection that is built into it as well. It's really close, you see that wire coming up there, to this wire here. It's really hard to see, and I'm sorry, but that's a little too close. I mean, they're trying to get you this far apart with your wire connections, or this far apart from right to left side of your outlets or sockets. This is the smallest thing I could find with the worst possible spacing. But yeah, you want to wrap it with tape, just in case something gets across it. One little bug can start a fire. It's true. Now, aside from 7 minutes and 18 seconds of me showing you how to make a connection that is a lot more mechanically stable to the point that I only do this. I don't use pliers to bend the wire. I strip the wire with a proper wire stripper, and then I do that. And in stressing it that way, it never comes loose. And again, if you're going to be dealing with the wires being pulled in and out and you got a lot of flexing going on, then suddenly you want it to be slightly loose so that when you push your outlet or your connector in, you very quickly give them all a tighten down, a real quick one. I'm going to still do this. Even though it bends the wire and may stress it a little more, I end up with connections that I'm sure cannot loosen themselves even during a fucking earthquake. I did this to a trailer house because the previous owner's trailer house, when they were moving it, it shook wires loose and one of them came loose. And it literally came off there. This is the only high reliability thing I know of to do for wiring like this, so I'm going to do it as a video. Other methods for making it a bigger connector rather than a small hook, J-hook or whatever, shepherd's hook, they don't work. This does, if you were trying to do it. Otherwise, just use the standard little J-hook, put it in there, and it'll have a little more play in it. It still gets good connection, but I'm serious. You can hang a coat off that. It won't move. Now we're going to talk about the stabbies. How to remove a stabbed-in connector because you don't want to leave it in. I'm not a hater on these, but let's get some practicality here. First, you find a little slot next to the little hole in the back that the wire's stuck in. You're probably wondering, is that part of the design? No, it's not. When you push in your screwdriver, it should lean one direction. Get it in there and then push the opposite direction, and you should be able to remove that wire that was stabbed into that hole in the back, that hole back there, which is, again, very, very terrifyingly right next to the connection. Well, they're the same wire. They're the same electrical connection, but you'll want to remove these. Now, why are those used? Now, there's two reasons to use it. I'll get to the point on that. Very low current usage of the wire that's being stabbed in. It's, in most outlets, not all of them, an extremely low quality connection. It has very little metal surface area, so unless you're going to keep it like really low current, like really low wattage, less than 100 watts, honestly, it's not going to be safe. Now, where did this come from? If you're not aware of it, originally, when wires were plugged in for any purpose, they were always just wired in, as in electrical wiring. You the equivalent to me putting screws and nuts and bolts together like this, that's how you hooked up a lamp temporarily. There weren't any temporary electrical connections except, well, I'll go into the history of connectors if you want, but you can look it up anywhere. The point is, one of the many methods was to use a stiff piece of wire, sometimes with another piece of wire wrapped around it, soldered to it and insulated, just jammed into a hole. Yeah, instead of an outlet with metal blades that are broad with a lot of surface area to make good connection, they used a push pin socket, aka jam a chunk of wire in it. That was done. Yes, a live outlet sitting there where you jam in a bare wire and a jam in another bare wire. You had to know to put in the neutral wire if it was even neutral, and then put in the hot wire. For some reason, that's a good idea. Oh, that's a lot safer. The other method was to have an outlet that had a switch on it. That's where partially the tradition in many countries like Britain, you have outlets with a switch next to it, or it's integrated in so it doesn't go live until you finish plugging the plug in. That's where it came from. And some of the connectors you already know are just push pins. Now, I want to point out that some of you who are electronics engineering technicians or just geeks who do wiring know that microprocessors and old-style microchips used a very interesting connector, hint, hint, where you have really tiny wire you jam in. It was for putting in wires in a prototyping board, and you could just pull the wires out. They were based on having two metal surfaces like this that you put in the wire through from here, but on the bottom it also bowed back out, spring-loaded against each other, standard electrical connector for low power, low intensity, and they're high reliability. But isn't that what's in here? Oh, fuck no. Some of them do have that. The ones that are really good, and you have to smash them to find out, have a high reliability backstab connector. I've seen 2 in my lifespan. Yeah, true story. The normal good ones that are still shit have a nice surface area where the wire presses against it. And on the other side of it is a spring-loaded plate that pushes against it. The backstab connectors primarily, you see, have a gouging, biting edge blade or leaf. The ones that are leaf-based, where it curves back out, are the high reliability ones. They still have a very little surface area, but they're not as bad. But this method is really bad. Now, the way you tell whether or not you got the good one versus the bad, God help me, I'm going to do this. You just stick the wire in, a test wire, and put a bend in it, like that. You stick it in the backstab connector, like so, push it in, and then you give it one full rotation. Now you have to go in with your screwdriver that will tilt to tell you the opposite direction of pushing it. Push your screwdriver, pull it out, and then look at the surface and see if it made a nice deep gouge. It did. This is to make it to where the wires can't be pulled out because you're going to push the socket in and out. Okay, but that also means that it has like 1/100th of a millimeter connecting it on one side, and in some of them, only. They're supposed to have a broad surface area and then the blade grabbing, and then it'll gouge in, and if you rotate it, it'll cut into it, but it'll still have surface area. But that'll tell you whether or not it's using the biting blade or a nice soft leaf surface. Soft leaf surface ones, they can also bite as well, but most of them don't. Unless you smash it, you don't know if it has a big surface area. It needs a big surface area for electrical connections. So unless you want to sit there and take one out of the sample of hundreds of sockets you may have, or plugs or switches, and determine whether it's the good kind of backstab connector that's eventually going to get phased out completely, unless you're going to do that, don't use the backstab connectors except under one condition. Plugging in stuff that isn't going to matter if it goes bad, like a little socket for running a little low-power light, like track lighting on the walls or whatever, maybe is acceptable in your area. It's UL standard. You can use these push things. But the original design, by the way, in the old days, was a really high reliability connector for you to jam bare wire in. It also had a little toggle handle on it, but that's gone. So unless you see, factually, it doesn't do a gouge, or you can smash one to take it apart and make sure it has at least one good surface area leaf that's nice and straight, don't use them. And yes, this is my little gift to the internet for the day. Ha ha ha. But yeah, doing that with your wiring will make it to where it's almost impossible for it to wiggle loose because it can't move. And it has just as much surface area because it's done the same way. And I'm going to call it the extended J-hook or shepherd's hook that makes it mechanically unable to wiggle loose. Thank you for watching. Have a good day. and I wish all of you luck with it.